without further ado, let's get started with today's lesson. Okay, now I've got two questions for you tonight. These are both exam type questions. So you'll see the format. We want you guys to get used to the exam type format. And each question can be done by both grade 10 and 11. So I've made sure that these are both doable. They are a little bit challenging, but if you understand what the question's asking, it shouldn't be too difficult. All right. So the first question we're going to do is a question about someone that wants to put a trampoline in their backyard. All right. So here's the trampoline. So this person, Timbin Corsi, he wants to put a trampoline in his backyard. And this is the diagram to show the hole that needs to be dig, which matches the dimensions of the trampoline. All right, so this trampoline is going to be in the ground. Okay, so let's read the text here. It says, this person has started by digging a hole in order for the trampoline to be placed in the hole. Although Timbin Corsi has used some of the dug up sand from the hole, he has 2/3 of the sand left over. So he's dug a hole to put the trampoline in, and he's got sand left over. He's got 2/3 of the sand that came from the hole left over. The other 1/3 he used somewhere else. Okay, a company is prepared to collect the leftover sand free of charge, provided there is more than 5 meters cubed of sand. So this is important here. Okay, so a company is collect the leftover sand free of charge, provided there is more than 5 cubic meters of sand. Okay, so when this hole is dug, to get rid of all the sand, a company will come pick it up, but it's got to be more than 5 cubic meters. So that's obviously going to be one of these questions that we're going to answer here. Now, looking at this diagram, this is perimeter area and volume. What shape do you guys see? Please, someone, you tell me. You can raise your hand or you can put in chat. What shape do you see on your screens? All right, we got a wide circle, a circle, good. Cylinder, good. Good, Kulu, that's good. Cylinder. Yep, that's it, David. All right, it's a cylinder. Okay, so we do have a wide circle. You're right, there's a circle on top. So it's a 3-dimensional image. There's the circle on top there. And the circle has a height to it. All right, going this way. And because we have the circle area at the top and the height, that makes this a 3-dimensional image. Okay, very good. What else do you guys notice about this diagram? There's something very important that I think you need to notice. Can anyone notice anything about this diagram? We're given 2 dimensions. Anyone pick something up that they think, oh, that's interesting? The units. Zondi, you're making, you guys are on the money. That's it. The units are something we need to be careful of. And Sonia's put it in there. It's in meters and centimeters. Did you see that? We've got meters over there and we've got centimeters over here, which is not very good because we want to work with one specific unit. We've got 2 different units here. And the question, if you remember the question at the bottom, I've highlighted it with red on the bottom there. They say we need to check if there's more than 5 cubic meters. Okay, now we've got meters over here in the 1 dimension, but we don't have meters here on the right hand side for the height. So I'm thinking we might need to convert that during this question. Okay, so before you even see the question, you take a glance at it, you understand what shape it is. Okay, and if you understand it's a cylinder, then you can kind of have an idea of what formula we might be using for this. And looking at the dimensions are different, and the question is referring to cubic meters, but we've got meters and one of them is in centimeters. So we're getting an idea of what we're dealing with here before we even see the question. All right, so all information that we're gathering. Now you might think, sure, Teacher Dale, we spend quite a lot of time investigating this. Do we even have time for that? You don't have to spend a lot of time looking at the diagram and investigating. Okay, so when you first see this diagram in the exam, your mind, because you've you've practiced in class, you've done some Watobe lessons, and you've seen the textbooks and things like that, your mind will understand or have seen and recognize the shape. Okay, you might not think you're excuse me. You might not think you understand all the shapes, 100%, but you do have an idea of what this is. And subconsciously, it might not be a direct thing, but subconsciously you will have an idea of what to do here, okay, just by glancing at it. But it's good to pick up that we've got meters and centimeters in one diagram. Always good to check that. All right, now let's have a look at the questions. All right, so here's question number 1. I don't want you to look at the second one. We're dealing with one question at a time. Question number 1 there at the bottom. It says, calculate the area. Calculate the area of the base of the hole. So remember, this person's digging a hole and it's going to put this trampoline, it's going to fit it inside the hole. So it says calculate the area of the base of the hole in square meters. So we need area calculation in square meters, and we need to round off to 2 decimal places. Well, we know we always need to round off to 2 decimal places, so that's not something new. It says you may use the formula. They give us the formula. Area equals pi r squared, where r is the radius and pi to use is 3,142. So they're giving us everything we need for this. All right. So this formula area needs radius. All right. How are we going to get the radius from our diagram? Can anyone tell us? Can anyone tell us how are we going to get the radius from this diagram? Where is the radius? So Alzondi says the diameter. Now, Alzondi is referring to 4.3. Everyone's saying 4.3, 4.3. Okay, so look at the 4.3, teacher now. All right, so I'm looking at the 4.3, and here is the 4.3 at the top. All right, everyone's saying 4.3 diameter. Okay, but that is a diameter. So how do we calculate radius? There we go. Sonia and Dave, well done. Chiamo, very good, very good. You guys know what to do. You see, you know what to do. All right. You know what to do. So we're going to divide this diameter by 2. Okay. What else do we need to do before we go to this formula? Well done, Dave. Good job. What else do we need to do before we go into the formula? Because we can divide that by 2 and just go straight into the formula and start calculating. But shouldn't we do something else first? Can anyone tell me? Do I go into the formula now, or is there something else I need to do? All right, good job. Alzondi and Sonia, convert. Okay, so they're saying, look at this 90 centimeters here on the right-hand side. That needs to be converted because our question says, very good, Chairman. Our question says they want square meters. If you look down at the question, they want meters, but our dimension here is 90 centimeters, so that might need to be converted. Do we need this for the formula? No, we don't actually need this for the formula, but that one there will need to be converted if we're working in meters sometime or another. We don't really need this for the formula. We can actually take just that one dimension and go, because the 2 parts that we have here, one is pi, which they give us, and one is radius, which we can get from the diameter. So we can actually go straight into this formula here. So we can say, I'll do it on the side here. A for area, A equals, I'm going to write the formula out again so you guys can see, pi times r squared. Okay, so now we're going to sub in all our values, substitute in all our values. So we're going to got 3,142 and multiply by the radius. Now I'm going to put a bracket here because I haven't divided the diameter yet. Okay, so I'm going to put a bracket there to show that I need to divide the diameter, and then it'll give me the radius. Once I've done that, once I've got my radius, I will need to square it. So that little bracket there is waiting for the radius calculation. Okay, so I'm going to sub in my diameter in here. So I'm going to move this over slightly, make some space. So in here, I will show the marker. I will say, look, I know what I'm doing, 4.3, and I need to divide that by 2. Okay, so I'm telling the marker, I know I need to divide the diameter by 2. All right. And then we can reach for our calculator to do all the work for us. All right, so our formula is ready. We can go into our formula with this. I'm going to move this calculator over a bit so we can see the calculation. So 3.142, and I need to multiply this by, I'm going to put everything in. All right, 4.3 divided by 2, and then this needs to be squared. Okay, so look at the formula on my screen. If it's too small, you can see it there. All right, so on 2 screens there. So we've got 3.142 times, there's the diameter in the top. Cut it in half to get a radius, and this whole bracket now is the radius, and that is going to be squared for radius squared. Okay. All right, we're going to press equals here, and we're going to get 14 comma. I'm looking at the second decimal, which is a 2. Does it change? No, it doesn't. So we're going to have 14 comma 52. All right, now what units are we working in? We put in meters. This 4.3 that we put in is in meters, and I didn't write the M there. And I know kids thinking, oh, Teacher Dale, why did you not show the units there? I'll tell you why. I'll tell you why. Okay, because I've seen marking, and when students look at this type of question, what they sometimes do, I'll show you here on the calculation, all right? So have a look here. So what they sometimes do is they'll write meters there. And then sometimes, like I've got brackets to isolate this calculation. Sometimes they'll put the 2 there. They're putting the 2 on the M. All right, so that 2 needs to be applied to only the numbers. Okay, so that's why I'm worried about putting the M there, because sometimes people actually put that 2, the power of 2 on the M to make square meters. Now this 2 at the end here is different to this 2 over here. They're 2 totally different things. The top 2 is being applied to the calculation, applied to the number. The bottom 2 is part of your units. Okay, please, please, please do not go and put a 2 here on the number and then go and square it again. All right. This 2 at the bottom belongs to the meters. It's part of the units. This 2 at the top is part of the calculation. All right, don't get confused. All right, I see that happen often. Are there any questions about this? If there are no questions, we're going to look at the next one. I hope you guys are all getting this kind of answer.
It's so silent and worrying.
Yeah. All right, let's have a look at the next one. If there's no questions, I've got lots of them. I've got lots of examples tonight. Good. All right, so moving on. Well, not lots and lots, but I've got a similar example below, and that's going to be yours. You guys are going to do the last one on your own. All right. So question number 2. Determine, showing all calculations, whether there is enough sand for the company to come and collect it free of charge. Now, if we look at our question again over here, they said for the company to come collect free of charge, the sand that he's going to remove has to be 5 cubic meters. Now, let's read this again, because there's an important thing above here that we haven't looked at. It says, I'm looking at the second line. Although Tembin Corsi has used some of the dug up sand. Now, where's the sand coming from? So he dug a hole to place this trampoline in. And this diagram is for the hole. He dug a hole. He used some of the sand already. He has 2/3 of the sand left over. And that's the sand that he wants them to take away. Not all of it. 2/3. All right, so we've got to be careful here. We're checking on 2/3 of the sand that's been dug out. Now, when you look at this diagram, this looks like a cylinder, like an object that's sitting on the ground. But actually, that is a hole that's been dug out. So the hole is in the shape of a cylinder. All right, so and all that sand inside that hole, inside that cylinder, has been removed. And if you have all the dimensions here, we've got area of a circle, which is 2 dimensions, and then we got height, which is a 3rd dimension. This is 3D. So 3D is volume. Okay, so the volume of sand needs to be accounted for here. And then we're going to check 2/3 of that volume and see if it's above 5 cubic meters. If so, he can ask the company to come and take it. All right. So the question says, determine, showing all calculations, where there is enough sand for the company to come and collect, whether there is 5 cubic meters. You may use the formula volume equals area of base. All right. Multiplied by the height. Okay, now think about it. Which base are they talking about? We highlighted it in the top. I'll give you a clue. There's the area. All right. When they say base, that area can be on the top or the bottom of the shape. Okay. So there's actually, I'll try and draw it. There's another circle at the bottom here. Okay. So that area, that circle area, could be at the bottom as well. Doesn't have to be at the bottom. They can put it on the top or the bottom. It's the same thing. Okay. So it's that area of base that they're talking about, which we have on the top. All right. So that's the area that you're going to use. And you're going to multiply by the height. Okay, I'm going to let you guys try this. I'm going to give you a couple of minutes. Let's see what you come up with, and then we're going to have a look at it. If there are any questions, guys, please feel free to ask. Nicholas is in the dark. It must be load shedding there.
Yeah, that like came back so quickly.
There must be load shedding there. You okay, Cody? Cody's scratching his head like, oh my gosh, where do I even start? You okay, Cody? You got this. Come on, Cody, you can do it.
We believe in you.
We believe in you. Ah, there's Ave. Gone. Well, I'll give you a few more minutes. There's quite a bit to consider here.
Wow.
There is quite a bit to think about. Yeah, there's a few things you have to consider. You got to work out the volume, and you got to work out. I don't want to give too much away. You got to work out the volume, do something to it, and then check it against 5 cubic meters. Ah, Tiamo, come on, you can do this. No, the area of the base is already meters squared. So the area we calculate is in meters squared. So that's in the correct units. Okay. But there is a dimension on the diagram. I'll go back up to the diagram. There it is. I'm just showing you the dimension there in the diagram. That will need to be converted because that's centimeters. All right, Sonia's got a volume.
Tiamo wants to be fried again. Are you seeing this?
Oh my God. Tiamo.
So early in the lesson. No, man.
All right, so Keela's got an answer there. Ave is very lost. All right. So this example, this question is quite similar to the second one. So if you're lost on this one, don't worry. This you're going to try the second one as well. All right. So you got to work out a volume, and the formula is there at the bottom of the question. The only thing that comes from the diagram, and I'll write it here, is height. I'll write it here. That's 90 centimeters. All right, we're getting some answers now. I'll give you a few more minutes. All right, answers are coming in.
Second first.
All right, we've got some numbers coming in. All right, so Mbula, you answered something there. All right, that looks like the volume of this hole. Okay, just remember now that this person used 1/3 for himself, and it's the 2/3 that he is worried about. Are they able to come and collect the 2/3 of the volume of this hole? He used 1/3. He has 2/3 of sand left over, and that's what he needs to check. All right. Let's have a look at this one. If you're still working on it, keep your calculations there and then check as we go through this. All right, so the first thing we need to do is work out the volume of the hole. He's digging all the sand out the hole, so we need to work out the volume. Okay, they give us a formula, area of base times height. Now, these words here, area of base. That's from the previous question, right? You see there, area of the base. So we've done that calculation. Here it is. It's 14,52. All right, so we're going to use that because that comes from the previous question. So volume is equal to, I'm going to go straight into putting the numbers in, 14,52 times the height. Now the height, I'm going to do a calculation in brackets. You might do that before, or you might do it on the calculator and just show that here, but I'm going to do all the calculations. I'm going to show it in a bracket. It's a separate thing that I want to do. So from 90 centimeters to meters, I've got to divide it by 100. So I'm going to say 90 centimeters divided by 100 to give me meters. Okay, so let me just rewrite this. I'm just showing you all my steps. So this is going to give me, like you guys said, 0,9 meters. Okay, so now I'm working in meters only, which is what we need. And I'm going to get to the calculator now. And I think I saw this answer for a lot of you. Let's keep it here. So 14,52 multiplied by 0,9. Okay. 13,068. 13,068. Now, I'll write that out and then we'll round it off on the page. The 13,068. And the units are now meters cubed. Okay, so we multiplied our square meters by our meters and we got meters cubed. Okay, I'm going to round this off. So I'll put my little squiggly sign here to say it's rounded off. In fact, I'm making a big mistake. What mistake am I making? I almost rounded this off and I said this on Tuesday. Who recognizes the mistake I was just about to make? I wanted to round this off. Should I round this off? Should I round off now? When should we round off? Who can remind me? When should we round off? The only time that you round off. Anybody in chat, when should you round off the question? You're doing a long question. When is the best time to round off? The
Yeah.
final, that's it, Dave. The final answer. Okay. So now this 13,068 is not the final answer because we still have to work out 2/3 of this. All right. So this is all the sand that came out the hole, but Dave isn't trying to get rid of all the sand. He's trying to get rid of 2/3 of it. Okay. So let's work out 2/3 of this. So I'm going to do it over here on the left. So 2/3 of this volume, and of means times. So 2/3 times 13,068, keeping my decimals and keeping my units there, equals. So 13,068 times, oh, let me do it the right way around. Let's say 2/3. 2/3 times 13,068 gives me 8,712. So this is 8,712 cubic meters. All right. So this is how much sand is 2/3 of the hole. All right. I can round this off now if I want. So 8,71. And we're checking this against the 5 meters cubed in the question. Is it bigger than 5 meters cubed? Yes, it is. So let's read the question. Determine showing all calculations whether there is enough sand for the companies to come and collect. So this is bigger than 5 meters cubed. Our 8.7 is much bigger than 5.8. So yes, there is enough sand. Okay, so we have to make that statement. Is there enough? Yes, there is enough sand. Because we've just shown by calculation, 8.71 meters cubed is much more than 5. Are there any questions about where does the 2/3 come from? Cody. All right, thank you for that question. So if we go up to this, they say over here, he started digging a hole. Although he has used some of the dug up sand, which is the whole volume of this hole, he has 2/3 of the sand left over. Okay. A company is prepared to collect the leftover sand, which is the 2/3. So that's what we're checking here. Okay. So I think most of you probably worked out the whole volume, but we're only checking 2/3 of that volume. Okay. The 0,9. Good, Janu. All right. So the 0,9 that we used, the formula said, if we look at the formula over here, okay, the volume equals area of base times height. The area of the base is the circle that we calculated at the top there. We calculated that in question 1.2. So if we look at question 1.2, area of base, we worked it out as 14,5.2. They just want to know, what you got to multiply that by the height. So the height comes from this dimension here. On the drawing, it's 90 centimeters. Remember in the beginning, I said we're going to need to convert that, especially if we're working in meters cubed. So that 90 centimeters we had to convert. And if you look at my calculation over here on the right-hand side, that's where I converted it. I said 90 centimeters divided by 100 will change me to meters. And I need to be in meters for this question. Okay, that's it, Ava. Good. All right. Any other questions about this? Do you guys want to take a screenshot? I'll take a screenshot of, let me zoom out a little bit, of the whole question. There we go. You can take a screenshot of that, and then I'll move down to take a screenshot of the calculations. And then you can try this on your own. And then I'll do a run through of exactly what we did again. Okay. All right. So there's the top part of the work. And here are the calculations that we did at the bottom. Okay. Let me go through this one more time. So 1.2. 1.2 says, let's read it. Determine, showing all calculations, whether there is enough sand for the company to come and collect. All right. So if we look at the question, what sand is this that the company must come and collect? So it says here, he has used some of the dug up sand. He has, excuse me, 2/3 of the sand left over. The company is prepared to collect the leftover sand. So we're not working out if the company must come and collect all the sand. He used 1/3 and he has 2/3 left. That's what we need to check. All this sand in this hole, 1/3 has been used somewhere else. He's worried about 2/3 of it. Okay, so we're not just working out the volume of the hole, which will give us this 13,068 here. That's all the sand. He used 1/3. He has 2/3 left that the company must come collect. So we need to check what's 2/3 of that volume. So on the left-hand side here, we did a calculation to say 2/3, 2/3. You see, you could say 2/3 of the volume. All right. The word of means times, and the volume is this over here. Okay. So we worked out 2/3 of the volume, and we get 8,71. All right. That is much bigger than the 5. Oops. It's not squared. It's supposed to be cubed. The 5 cubic meters that the company says, if you're not more than this, we're not coming. We're going to pay. You're going to have to charge. All right. So if it's more than 5 cubic meters, so yes, there is enough sand for the company to come and collect without a charge. All right. So 1.1 is quite a straightforward question. 1.2, if I just told you guys, work out the volume of the hole, that would be very straightforward. But this question has a lot of text in it that you have to understand. All right. So it's a lot of interpretation. Like I said on Tuesday, the hardest thing about math literacy is not the calculations. You guys can look at these diagrams, they give you a formula, you can sub in the numbers, and you can work out these answers. It's not difficult. It's when they start asking you specific things that you got to find in the text. It's interpretation of the text that they give you. That is the skill that you need to learn as well. So that's what makes math literacy difficult. If matrics come out of a final paper and they say, oh, that paper was difficult, it wasn't because they didn't know how to use the volume formula or the area formula. It was interpretation of the question. Okay, so it's so important for you guys to be exposed to a lot of questions. I wish I could do hundreds of these things, because by the time you get to like the 3rd, the 4th, or the 5th one, you have experience now and you understand what they're trying to ask. The first time you see this, it's going to be a little bit confusing. Where must I look? What must I do? All right. If I just gave you the formula, work out the volume, you could do that. It's not that much of a challenge. But when they start hiding things in the text, that's what makes math literacy tricky sometimes. So let's see another question. All right, let's see what this one says. I'm not even going to look at this 2.1. Okay, we're going to move on to this one here. All right, here's a new question. Let's have a look. It says, the following diagram shows a drum that is advertised as 200 liters. Answer the questions below. Now let's have a look at the drum. First of all, this doesn't look like, okay, you tell me what shape you guys see. You tell me what shape you see. All right, good. Cylinder again. Now, some of you might look at this and say, sir, this isn't a perfect cylinder. This is why in the exam, on the cover page of all the exam papers, they say drawings are not necessarily to scale. So the drawing might not look exactly like a cylinder, but if it's a drum, it's a cylinder. Okay, so let's answer the questions below. Let's see what else they give us. They give us diameter, but where's the number? Oopsie. Sorry, let's go down. On the diagram, there's no number there. And in the height, there's no number there. But they do tell us down here. So they're trying to make it even more difficult for us. Why not put the numbers on the diagram? Well, we can do that. You can write it onto the diagram if you want. If you're used to it, then put it there. So the diameter is 580 millimeters, and the height is 93 centimeters. All right, what do you notice so far? What do you guys notice about the diagram and the dimensions we have so far? Units. All right, good, Lataba. We're checking the units again. Okay, so yes, the units are different. All right, so we need to check on that. It's a quick thing. Just look at it. Units are the same, then don't worry. But if the units are different, one of them is probably going to have to change. We've got millimeters on the top, and we've got centimeters here on the left-hand side. All right, so let's be careful of that. One of them is probably going to have to change. All right, let's move down. You may use the following. Now look at this formula. Volume of drum. This is a cylinder. If I go back up to the top formula, that was also different. In fact, the formula that I showed you guys when we did volume of cylinder was V is equal to pi times R squared times height. That's the one that we actually learned. But they can give it to you in a different way. So the pi is over there, radius times radius is radius squared, and height is the h over there. So it is the same, it just looks different. Don't let it throw you off. It's a volume formula, the same one that we used to, and they say pi is equal to 3,14, 3,142, sorry, so we'll use that. And then they give us something down here at the bottom. I don't know if you can see it. That is a volume to capacity conversion. We spoke about this when we did the conversion section. So that is a volume to capacity conversion. So this formula down here is for volume. All right. And if you look at the top here, they talk about 200 liters, which is capacity. Okay. Our formula for volume doesn't work out liters. It works out cubic meters, cubic centimeters, cubic millimeters, things like that. But the question is mentioning milliliters. So somewhere along the line, we will have to change from volume to capacity. And they've given us this conversion in the statement over here at the bottom. All right, so we're probably going to use that as well. All right, here comes the question. Show with necessary calculations that the volume of the drum in liters is actually different to what is advertised here. So check the volume of the drum in liters and see if it is 200 liters. Okay, now the dimensions are over here. They were on the diagram. They're also written over there. You've got a formula. All right. Let's see how you guys do with this one. Just remember, when you work out your volume, you're going to have to change that to liters. And the formula that we've given here for the change, look at the units that they want you to work in. Centimeters cubed. Okay, so the diameter will need to be changed to centimeters before you go into the formula. All right. So I suggest work out the volume first and then use this conversion to change it to liters. Off you go.
Latava says, can you please scroll down? I can't see the top of the drum.
Okay. I can show you that diameter there is 580, but just remember that the units are also here on the side. So over here, they're also written there. So it's the same units as I showed on the diagram are also written over there. It is
Or
580 at the top.
maybe you could zoom out just a bit so that they can get like the full question, maybe.
Okay. And I'll move this 580 down to sit there. Right, there we go. Everything's in the picture there. I hope you can all see it. For anyone that wants to know, this was a 5-mark question in the exam. Yeah, well, don't say it.
We're not ready to hear it.
No, no.
We are so not ready. It always starts with like an emoji,
Yeah,
and they give off a warning saying that I'm
yeah,
gonna
it's
say
coming.
it.
I'm gonna say it. Surprise. Yeah, that's better. That's better to say I'm surprised. Yes.
Maybe Tiamo's gonna drop an answer soon.
Yeah. It's just trying to trick us. You know what, grade 10s and 11s? I'm walking you through these questions, and I think after the second one it'll make more sense. And as I explain this, it makes a little bit of sense. If you get something in the exam that's similar to this, you will remember, you will have recollection. But what if you get something a lot easier than this? It's going to feel real good. It's going to feel real good when you look at the questions like, what? They got the same units. The formula is easy. I just sub in. I get the answer. Oh, it's too easy. All right. So I was on you. So radius times radius. They say radius times radius. I don't know why, but radius times radius is radius squared. It's the same thing. They're just trying to confuse us. We will not allow it.
No confusion will stand in the way of us getting the answer.
Oh, they can try, but they will not succeed.
Yes, I am Bongwa. I just typed really quickly.
All right, so by now you should have an answer for the volume. Don't forget that you will need to change your volume, which should be in centimeters cubed, into liters by using the conversion underlined in blue at the bottom of the statement. Ave is finished. Ave's like, that's it, I'm done. Ah, here it is. Come on, guys. You should have the
No,
volume. You should have the volume at least. I'll be happy if you had the volume, and it's not that hard from there. Ah, Sakile. Fantastic. Sambulo, fantastic. Excellent. The answers are coming out. It is tough out there, Janu, but you
be
don't
tough.
yes, be tougher. You don't succeed if you get it easy all the time. It's got to be a little bit tough sometimes. All right, Sonia. She's been quiet. She's been working. All right, from from skeleton to answer. Mm.
Wow. Sakila says their brain cells just died.
Sakile did it, and now he's like, that's it. My brain is finished. I can't anymore. Don't worry, Sonia. Let's see what you did. All right. If you make a mistake, when we go through the calculation and you see, I just made a silly mistake, that's fine. All right, here we go. You ready? So we need to work out the volume of the drum. Teacher Dale likes to show everything in one line. So I'm going to say pi is 3,142. That's the radius. We need to times by the radius, which I'm going to do this, okay? Because like we said, radius times radius is radius squared. So when they say radius times radius, I'm taking it as radius squared. It's the same thing. Okay. Now, radius comes from diameter. So I've got to take my diameter. Oh, I'm going to have to do a couple of things at once here. In fact, before all this, let's change this diameter. Let's change this diameter. All right. So I'm going to change it to, I'm going to divide it by 10 to get centimeters. So we got to work with 58 centimeters. All right. That's the diameter we're working with. Convert it first. Then in my formula, I'm going to take my diameter, which is 58 centimeters. I'm going to cut it in half to make a radius. All right. And the radius must be squared. Okay. Not only that, but I've got to multiply by the height, which is already in centimeters, so I'm safe. All right. So I've got a radius from my diameter. I converted my diameter, and it's all in the formula now. Okay. Thank you, Sambulo. Good stuff. So this should be ready to go to the calculator. All right. So 3,142 times, I'm going to use a bracket. Whoops. Okay. So 58 divided by 2. And I want to square it. And then times that by 93. Now, Teacher Dale likes to put all these little bits and pieces in one formula. If you want to do a small calculation first and then come and bring it into the formula, that's fine. If you want to work out the radius first before coming to the volume formula, that's fine. I'm showing all the little bits and pieces in one thing. Okay. All right, I'm ready to press equals. Yo, that is a big number. So we've got let me read it again. 245,745. 245,745, comma 246. All right, what units are these? I'm working in centimeters only in my formula, so these must be, for volume, centimeters cubed. Okay, so that was step number 1, work out a volume. And you all should have something similar to this. Check what's on the board, what's on the screen. See if you've made a mistake and why you're not getting this answer. All right, now, I'm not going to run this off. We're going to practice not running off until the end. Okay, so I'll take my volume now, and I'm going to come down here on the left and the bottom there to come take this conversion and apply it now. So the conversion says for every 1,000 centimeters cubed, you have 1 liter. So how many thousand centimeters cubed do I have in this number? Well, can anyone tell me how I'm going to work that out? How do I work out how many thousand centimeters cubed I have in this number? What do I do to this? Divide, Sonia. Thank you very much. So I'm going to divide this and say, I should say capacity. The question said volume, but they should actually say capacity. The capacity will be 245,745, 246 divided by 1,000. All right, so I can take this answer and divide it by 1,000. In fact, let me show the whole thing. 245,745, 246. I'll do it all here for you. Divided by 1,000. All right. That gives me 245,745,245, 245,745,246. All right. And as at this point, I will round off. Looking at the second decimal, which is a forward, is it changed? Yes, it is. So 245,75 liters. All right, liters. So coming to the question, show with calculations that the volume of the drum in liters is different than advertised. Yes. They're not asking, is it different? They're saying it is different. Show us that it's different. It is different. This is what we're getting now. Well done, Sakile. Well done. That's fantastic. All right. Well done, Ave. From skull to answer. Sonia, fantastic. Sakile, very good. Well done. Okay, well done, Sakile. That's brilliant. All right. So we did check. It's 245,75. Now, the next question is subjective because they're using the word explain. All right, explain. So we can use words here. And if your reason is understandable and makes sense, they will give you the marks. All right. So looking at the two answers, we've got 200 in the advert and 245,75 in the calculation. Why are the volumes different? Why did they say 200 liters in the advert, but actually it's 245,75? Would anyone like to give it a guess? This is a subjective answer. You can use words, no calculations. Why do you think they've done this? Why they said, here's a drum advertised for 200 liters? Anyone like to try? Why did they say 200 in the advert? Very good, Akil. That's brilliant. They estimated. Well done to both of you. They estimated. They estimated it's 200. Rough estimate. Okay. Anyone else? Very good answers. You'll get your marks for it. All right. No calculation needed. Anyone else have anything different? Why do you think it's 200 when actually it's 245,75? All right. Some people are probably still typing. While they're typing, I'll tell you what else you could have said. You could have said maybe they rounded off to the nearest 100. Okay. Yes, maybe they maybe they rounded off to the nearest 100 as well to make it a nice round number. Often when you advertise containers, they round off to like 200 or 250 or 100 or 50. They're not going to put exactly 245,75. So maybe they rounded off as well, but your answers are perfect. Okay. I think you guys have had enough. Like Sakil said, his brain is fried. It's time for the poll and the link to the quiz, please, Kia.
Right, I'm gonna drop everything all at once. Harvey is dead.
Fried.
All right, just get started on the poll. So long. And then the quiz link is gonna come up soon.
Ravi Lord, there it is. Thank you, Chama, for waiting till the end for saying it.
Yeah, at least you can ride until the end, like when you made it to the end, not in the middle. All right, so I have dropped your guys' link in the chat. I think I'm just gonna pause the chat for a bit so that everybody can just get a chance to get the link, and then I'll open the chat again. I know you guys want to say some nice things to us, but I just want everybody to get the link.
I don't think they're going to be nice things, yeah.
Excuse me.
But I hope you guys see that the calculations are not that complex. We're just using the formulas that we learned. The trick is interpretation of the question and finding exactly what they want and then changing a few things before we go into the formula. All right, so it's interpretation of the question and extracting what you need to do to get through the question. Okay, that is the trick. And you only get there by practicing a lot of questions and being exposed to a lot of questions.